Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of second order differential equations. Here we have the basic form of a second order differential equation in which R of t, S of t, and Q of t can be functions, but we're only going to treat the scenario in which they're constants. So here what we do is we look at f of t, and depending on what this f of t is here, it's either going to be called a homogeneous equation or a heterogeneous equation. If f of t is equal to 0, then it's homogeneous. If f of t is a function, it's heterogeneous. On this one, we're just going to do homogeneous equations. Another video will deal with the heterogeneous equations. However, when you're doing heterogeneous equations, the first step is to find the homogeneous solutions to make sure there are no repeated roots. So make sure you know this before you go on to heterogeneous equations. So what are the steps? First step, find your characteristic equation. Okay, how do we do that? Well, whatever the derivative power is going to become your exponent of your r being in some arbitrary variable. So let's look at an example. Here we have a y double prime that becomes an r squared, single prime becomes an r, and no prime becomes just the constant in front of the y. Okay? Triple prime becomes a cubed, no derivative power, so we just put the negative 1 down. All right? So then you solve it algebraically, just like you would do any other equation, and you'll have 3 possible roots. Depending on what the roots are, you will have different general solutions to your differential equations. First scenario. We have 2 distinct real roots. Let's say R1 is 2 and R2 is 5. Well, you would put a 2 here and a 5 there, and that would be your general solution. Okay? With all these general solutions, just like always, you can be given initial conditions, y of 1 equals 0, whatever they give you, and you can solve for C1 and C2. Now, in this case, you're going to get systems of equations. It's not going to be as straightforward as a linear differential equation or first order. So if we have a repeated root, scenario number 2, what happens is we have the overall equation becomes r for every exponent, but for however many times it's repeated, we need a t to some power. So the goal is not to have the same root written twice. So if we have 2 roots, we'd have c1 e to the rt, c2 t e to the 2t. So for instance, let me give you an example, I guess. I'll do a third one. So let's say we had r plus 2 to the 3rd power. Ooh, that's a horrible 3. What you would have is y equals c1 e to the, if you set that equal to 0, you get a negative 2. E to the negative 2t. Now, because we can't have a repeated root, we do plus c2 t e to the negative 2t. Are we done? No, because that's a 3. We have to go one more. So it'd be plus c3 t squared e to the negative 2t. All right? So that's how you do the repeated roots. And then here, if we have an imaginary root, we do, let's say it's a plus bi or alpha plus beta I, whatever you want to put there, it doesn't matter. This could easily be an a, and actually that should be plus or minus, sorry about that, plus bi. And then that just would be your a right there, that would be your b. I don't want you to get thrown off if you don't like Greek lettering. But by now you should be very familiar with those symbols, and it shouldn't throw you off that bad. So here we have c1 e to the alpha t sine beta t, and then, so the main thing that you see is that it's an exponential function, then the trig, and then the same exponential function, then the other trig, sine, then cosine. All right? So make sure you check out, there will be a video for each one of these. The most important part is to practice this. If you practice it, you will see they're not as bad as they look. The textbook I use spends a whole chapter dealing with these. I don't think you needed really to spend that much time on them, but that's fine. Just practice them. You'll see they're not as bad as you think they are. So I hope I've cleared up any doubts you might have. Thank you and have a nice day.